Hello everyone, welcome back to Path for Cloud. In today's video, we are going to learn about the resource limits and the request, right? But this is a part of something called the scheduling, right? Let me go back to the notepad. So let's say if I'm gonna type here scheduling, right? So scheduling is what, right? We have understood when we discussed the Kubernetes architecture, like we have something called controller manager, right? Where we have the node controller, where we have the replica controller, right? And apart from that, we have the scheduler as well, right? Scheduler, what scheduler will do? Scheduler is responsible to schedule your workload, right? Workload is what? Our code, right? Our application, which is running in the form of code. These pods will be scheduled to a desired node, right? So, but how come? Like, how come it will be getting that? Okay, which node is a desired node, right? Like by default, if you're not putting any kind of label, if you're not putting any resource limit or taint toleration, all these if we don't put, right, node affinity, no worries. Don't be fear about all these terms. We will discuss in very deep on all these, right? But yeah, uh, what I was talking is like if we don't put all these things, right, still what will be the steps to schedule will do, right? So obviously it will gonna follow the best approach, right? Wherever it find that the best node can accommodate those ports, it will gonna schedule, right? So that we have seen, where we have seen that okay, we need to put some kind of labels, then we have something called the selectors, right? These all things we have already seen, right? Then if I talk about that, apart from this scheduling, right, what else we will have? First thing we have already seen that label and selector, right? By default, what will happen if you don't put any of the node name, right? Like let's say you have only simple port definition file, right? So what will do that scheduler will use its best approach, and then it will gonna schedule those things, right? Then we have concept called label and selectors. If I put here, it will gonna check that okay, which label you have put, what is the selector you have put, right? It's simple, right? Label are just a kind of tag which we have already discussed. You can put on your object, right? And then selector will use or to filter out that labels wherever it get matches, that will be linked, right? Or it will be gonna deploy that particular thing, right? Then apart from that, there is something called taint and toleration, right? So for this, we will discuss in next video. Because today I'm just want to focus on this resource limit, right? And apart from that, we have the node affinity and this resource request and limit. So this is the scenario. Maybe for this scheduling, we have dedicated 3-4 videos, right? So taint toleration is nothing again that you are putting a label on node, because here we are putting that on particular ports, right? And using the other object like the replica set or maybe the service, that will filter out those label and get linked to that particular as a backend endpoint. Taint and toleration, where we are making sure that okay, a particular label is applied on that node, and whatever that not toll this board, right? Board will can tolerate that taint, right? Only those boards will be scheduled on that particular node. We will see. We'll take an example of here that kind of analogy of the toll tax, right? Like where we have the exception lane from ambulance or maybe some other cars, which can directly freely pass that toll tax, right? But on the other hand, you need to either you need to pay the toll fee or you need to get your car scanned with that kind of RFID scanner, right? That FASTag card. But we will see that in much detail going forward, right? Node affinity is again, it's a kind of again the taint and toleration, but it is a little bit advanced to this toll and toleration, right? So we will see that. And the next I would say that the resource request and limit, right? So this is the topic where I want to focus for today, right? So this is thing that we want to discuss here, right? Because it is very important topic, right? Not from the CK exam perspective, from the real time word cluster management scenario as well, right? like how you gonna manage. If I scroll up, so in last video we have discussed this dedicated namespace, right? So in this we have discussed something called the resource quota, right? Like we are defining the quota, some quota, and which will saying that okay, you can deploy only up to 5 ports. We have seen this, right? On the 6th port it was denying us. So similarly, let's say let's forget about as of now this app 2 development environment. You have only app 1 development, but still here you are developing some kind of different applications, right? Your user is working on a different stories, right, from the client request, and still you are deploying some application and you are doing, right. But here also you can put a limit from the resource and request. Now you will say that okay, what resource and request, because we have already put, right. But here what we have done is we have put the limit on the object, right? Like how many object, a kind of object you can deploy in a particular namespace, right? But to run that object, let's say pod, right? Obviously, to run a pod, at least we need some compute, right? Maybe CPU, memory, and disk. All these things we need, right? Without those, you cannot run. So for those also, we can put a limit. Maybe so and so application can use up to 2 CPU and maybe let's say 4 GB of RAM, right? If it is like requesting beyond that, probably that will not be allowed. Otherwise, all compute resources will be exhausted, and there is no resource will be left for the other ports and application, right? So that's also a possible. You can put this limit, right? So now let's come to this point. What is the resource request, right? So request is nothing, right? Request is something like the minimum of CPU and memory. Whenever a pod is get started, right? That scheduler will schedule your pod, right? So request is something that minimum that much of CPU and memory is guaranteed that it will gonna get, right? That's how that the scheduler will decide, right? Let's say if your request is for let's say 1 CPU and 2 GB of RAM, right? So first scheduler will look into the nodes, which node will have this much of compute, right? And based on that thing, it will gonna schedule your code on that particular node, right? That's how that request will come. Whereas on the other hand, we have something called limit, right? So what limit is? Limit is the maximum, right? Like request is something which a minimum, right? Like it is a minimum compute, and limit is something called maximum. Like this, beyond that limit you will not be allowed, right? You cannot go beyond that. So that's how that limit is, right? If you were trying to use that more compute which is beyond your limit, right? So Kubernetes throttles that, right? That means that it will gonna give a chance, like maybe there is a spike, so that's what that pod requested as so much of CPU and RAM which is beyond limit, right? So probably that will be ignored. But if your application is trying to make it attempt constantly, right, then probably your code will be terminated and it will be restarted again, and when it get restarted again, this request and limits will be enforced, right? But we will see that how it will be, right? Because in the case of CPU, that is I told you, right? But for the memory, maybe it is, you will see that out of memory killed error or something, that we'll try to see in action now, right? So in our what you call that, in seat also, right? Here you can see I have mentioned all these things, right? So in a cluster or node, we have 3 main compute which we have already discussed: CPU, memory, and disk, right? Same way, Kubernetes also needs all these to deploy this, right? And its scheduler will gonna get it. By default, when a pod is scheduled, right, Kubernetes assumes a pod or container requires a 0.5 CPU and the 2.6 MIB. It is a maybe byte, right? So I hope you guys are aware that the GB and GB byte or MB and maybe byte, it's just a different thing, right? Which is a minimum request, and from a pod and container can schedule, right? So that's what we have discussed, right? But still, it will be a kind of you need to understand, right, what it is, how it is exactly, right? Same way you can see that 0.5 is a 500 milli and CPU, and as much as low, how much you can define 1 milli at least this much of time CPU definitely will give you your code, right? Only your process, so that whatever that you are trying to do, that will be taken care, right? You cannot assign 0. Same way, the memory you need to assign, right? And what happen is when Kubernetes sets a limit, right? Let's say one CPU and this much of memory. If a container requires some more CPU and memory, it can go up to this limit, right? They can, yeah, that we have already discussed, right? They cannot go beyond with that. It can go only this much. But if we can set the limit to a container, request is something. Request is something. There is a typo. Let me correct it. When a pod is started, right, it can request a specified amount of CPU and memory in definition file. I'll show you. During its life cycle, if it is required more CPU or memory, right, that can it can go up to a defined limit for CPU and memory, right? For CPU, it cannot go beyond defined limit since Kubernetes throttled the CPU. What do you mean by throttle the CPU, right? Because if you see that we have discussed the virtualization, right, the container, right? And if you don't know about the container, like how exactly it is work, then there is a dedicated video on my channel that is something that Docker basic series, right? Go and watch. I strongly recommend go and watch to understand the entire, like the internal mechanism, how the C group will work and everything, right? So here what will happen is when you define a limit, right? So the limit will be defined to this particular thing, and when your code is trying to go beyond that limit, right? So what will happen? That C group will stop that, right? C group will only assign that much of resources in that particular namespace, right? And kernel will gonna kernel will gonna stop that. It will just put a kind of full stop that you cannot go beyond that, right? And what will happen is your code will be terminated and it will be restarted again, right? That's what we have discussed. And when it get restarted again, the limit and request will be imposed like whatever you have defined. For the memory also, that's what we have mentioned, right? It can go beyond that, right? For memory, but for CPU it is a hard stop. For memory, it can go, right? But if you're trying to go again and again, the same case, your code will get terminated and it will be rebooted again, right? So this is just the file I have created, right? And these are some additional link for the Kubernetes documentation. You can go. So let's come to our master node. So I have both nodes are ready, right? And okay, the CKA. Okay, let me clone quickly. Okay, it's cloned now. Let's come to our CKA labs. So here you can see what I have done is I have created these 4 new files, right? Let's quickly see what is this one. So here what I am saying is I am just saying that, oh, hey Kubernetes, schedule a new pod, right? Where what you can do is you can put a resource, right? Yeah, this is the way like you can do. This is can be done with the help of command line also, where you can put the resource request and limit the memory, CPU, all these things, right? But the best way and the recommendation way is doing it with via definition file, right? So let's say here what we are doing is till here we know that what we are doing, right? Only that these are few lines which is new. So we have a property called resources, right, which is for the container. And one more thing, like if you want to impose a request and limit, right, it cannot be done for the pod, right? It will be done for the individual containers, right? You need to put that thing in the container itself. So here we have the resources. What I have done is I have put a request, right? Like when a pod gets started, right, they can request up to this if application is required. That doesn't mean that the pod will started and the moment you start, that much of memory and CPU will be sent. No, that's not the case, right? It is something that if required for your memory, right, we are giving a kind of guarantee that this much of memory and CPU are for sure your pod will get, right? And during the life cycle, if performance is increasing, right, workload is increasing, and in that case your pod is required more CPU and memory, then they can go up to this limit. That's what we are defining here, right? So this is the resource. Under resource, we have something called request and limit, right? Under request, you have two memory CPU and same memory CPU. So this is the request and this is the memory, right? You need to understand this request is the minimum, right? That's the guarantee that definitely you will get when your code is started, and that time if application is required that much of CPU. And limit is the maximum during its life cycle. If they need, they can go up to this much of compute. That's what we are doing, right? So let's quickly do one thing. Create -f, and this is, I would say, okay. So now if you see, yeah, container is running now. Let's see, kubectl get ports, it is running. And if I describe this port, right, it is web1. Fine. So if you scroll up, so you can see that there is a section called, yeah, you can see that limit, right? So you can see the limit is 2 and the request is this one. So this is for this container. You can see this property comes for this web container, right? If you would have that another container, right, then you can see this indentation, right? This indentation will gonna start here for the new container, right? And that container will have a different limit and request if you want to put, or you have already put, right? That is the reason I have mentioned that this is for the individual container, right? Not for the port. So yeah, you can see this much. Now the question is how you will come to know, like how many CPUs and ports are getting assigned, right? Or maybe the currently used, consuming, right? There is one way. Kubernetes, not this kubectl describe node. Let's see what will happen to the node if I say k8 node 1. This is my node 1. Fine. If you go there, so here you can see that, right? This is the default namespace, and here in this default namespace, I have my container is running, which is the web1, right? And here you can see that this is the CPU request I have put, and this is the limit. This is the memory request, and this is the memory limit, and it is running for last 99 seconds. If you come to the allocated resources, right, how much memory and CPU, you can see that this much of request is already in consumed, right? It is already used, and this is the limit we have put. Similarly for the memory, you can see, right? Apart from that, there is something called, I will put the instruction in the description how you can set that, but let me quickly show you. What I have done is I have set up a local metric server here, right? You can see that this metric server is running here, right? With the help of this, if I say top port in my current, so here you can see this is the memory and the port I am running. If I cat this file, so here you can see what I have done is I have requested, okay, minimum is 500 megabyte and the CPU is 1, but as of now you can see that there is no CPU and memory is also less. So that doesn't mean that this will gonna give you at the time of creation. No, it is something when you are restarting your code, you are restarting, you are deploying your application, right? So we are giving a guarantee this much definitely will get. This comes again on the basis of your use case, right? So how we can increase it now? Okay, let's do one thing. Let's quickly expose this. Okay, get pods. Okay, so I will say Kubernetes expose. What I want to expose? I want to expose pod and web1, and I will say type equal to node port, right? So what I am doing is here I am saying this is something that we have already discussed, right? Many times we have discussed already, right? But just to show you like how it is working, and maybe because the main thing is what I am trying to do is here I am just saying that okay, maybe we'll try to kind of improve the load, right? Because as of now you can see that nothing is used, right? So what I'm trying to do is I'm just exposing it, this command, okay? So okay, web 1 is all expose service, right? You need to code is this one, kubectl expose pod. Do we have anything running? Yeah, there is one thing running. Let me see if it is this one. SVC web 1. What is the endpoint assigned? It is assigned this one, kubectl get codes -o void. So this is the information of our service. Come on, why it's stuck? Okay, it is already exposed, right? So what I will do is I will gonna copy this, right? And I'm gonna use this one. On that day, I think we have used, yeah. So okay, it is the same only, right? Yeah, it is replying. Now let's see if the load is getting increased or not. What was the command? Top port, right? Yeah. So it is probably it will get increased. Let's see. Let it run for yeah. You can see it get increased, right? We have some CPU assigned, so probably memory will also get assigned. So that's how that you can do this thing, right? If I'll open one more, because this is not probably a good example, right? Maybe I will put another example for this right? We have the stress load is coming. Another example there I will show you, right? But yeah, you can see that now it is getting increased, right? Now you can see that it is up and down. So that's what I was trying to do it, right? So this is the resource and limit, guys. So what I will do is now, let's do one thing. Let's delete this code. Delete code web 1. Okay. And now let's delete the service as well. So now, as of now, nothing, top port. So there is nothing, no load is there, right? This kubectl top port, right? This is coming from that metrics server, which I just show you in that in kube system. There is another supported port is running, right? Where our metrics server is running, and it is getting and collecting the usage of the CPU and memory, right? Now let's come back to our VS Code, and I will show you two files, the memory limit and the CPU limit. Maybe let's open this code as well. See, what we are doing is we are setting this resource and request at the container level, right? So here what is happening is this request and this limit, right, for a particular compute resources will be applicable only to that particular code, right? What if I want to put it for my entire namespace, right? Is it possible or not? Let's find out. So here, if you see, I am creating a new resource called limit range, right? So what I am doing is with the limit range, if you see, I am just creating a new limit range called memory range, and here I am putting some limit. The default is this one. This means is the request limit, and the default request is this one, and it will be gonna apply on the container, right? And it will be applicable to entire namespace. Similarly, we have this CPU, right? For CPU also this one. So let's see if I will gonna apply this. So what will happen? As of now, if you see, get I think limit range is the, yeah, you can see there is no limit range, right? So I will quickly create it, create -f, and if I'll go to the 10, and similarly I will apply the 11 as well. Okay, now let's limit. So now you can see that we have the two limit ranges are imposed, right? If you describe this, right, describe limit ranges, let's say CPU range. Okay, so here you can see that it is the default request, it is the default limit, right? Maximum limit. So that is how it's not happening anything, right? So it is just the default value we have set, right? Similarly, if instead of CPU, if I want to check for memory, okay, there was a typo, so let me fix that. Memory range, right? So here also you can see that for memory range also it is applicable to the default namespace, and this is the type for the container. Resource is memory. This is the minimum, maximum, default, whatever that we have set, right? Now what will happen is whenever you are putting any code here, right? That code, what it will do is it will automatically get this stuff, right? Let's say if I'll show you this file. So here you can see that, right? There is nothing defined for us, right? But if I quickly create a code using this file, right? And if I'm gonna describe this, describe code web 1. If you go up, right? So you can see that the same limit and resource request will be applicable. That's what we have mentioned, right? If I just take it here, so you can see that for CPU limit is 1. That's what we have put, and the default is 500 milliseconds, right? So that you can see. Similarly, for the memory, if you see for the memory, the limit is 512 megabyte and minimum is 256 megabyte, right? Maybe as of now, that is something that you are not using, right? That is fine. Maybe we can check top code. Right, you can see that you are using only 3 megabyte of memory, right? But I have very good example for you on this. So what I will gonna do is I will gonna delete this code web1 here. It's deleted now, right? So I have file called stress code for YAML, right? So here what I'm doing is I'm creating a code called stress code where I'm just running this predefined image for the stress, where what I'm saying is fork a 2 CPU worker, right, or 2 CPU process, right? Similarly for the virtual memory as well, and each worker will gonna assign 128 of megabyte, and it will be kind of 2, right? So probably it will be double. I think it is 256 around, right? So 256 of something you will get. That's what it is happening, right? And it will be happening for the 60 seconds, right? So let's do it for 60 seconds first, and then we'll do some changes and we'll see what will happen, right? So it is created, get pods -w. So it is getting created. Let's wait for it to be created. It is running now, right? Now, if I do the same thing, kubectl get top pod, right? Maybe it will take some time, but we will run it continuously. Kubectl top pod. Yeah, because it is a matrix, right? It will take some time to change. You can see that in every 2 seconds it will gonna change it. So now you can see that 721 MB it is coming, right? Milliseconds, sorry, and the memory will gonna take this, right? So that's what that you can see that right now it is getting that stressed, right? So here you can see how it is being done and everything. Let me explain you. Maybe it will not go beyond that. It will only for the 60 seconds. But let me quickly explain. So what we have done is we have set our CPU to 2, right? We are saying that 2, right? But the limit we have imposed 1, right? So it will not go beyond 1. That's what we have. Although stress command is trying to execute it for, because it is for 60 seconds. Obviously now that I think the code is done, it is no more running. So that's why that it is stopped. But let's try to understand what is happening is now. Yeah, it's the it is not running, so probably it will just let me quickly describe. It is saying that okay, it has pulled and started container. Nothing is showing here, right? So this is the we have put, right, and limit is already there, but it's not showing the current data, right? So you can see that again it has started. So that's how that it is going. But why it is not going for that whatever that limit we have put, right? We have mentioned here, if you see in stress, right? What I'm saying is just for the 2 CPU worker, right? That means that stress command will gonna use the 100% of 2 CPU. But if you see the limit here, right? What I have set limit set it to 1 minute, 1 CPU, right? So that is the reason this board will never gonna use the beyond 1, right? That is the benefit of this putting this resource limit, guys. It is a kind of a real example, right? If you are trying to do it, no, you will not be able to, right? What will happen is probably your it will never allow, right? It will never allow. That is the limit we have already imposed, right? So if a pod tries to 2 CPU, right? Kubernetes enforce that namespace limit range. That's what we have said, right? So by default, pod gets a 0.5 CPU. That's what we have mentioned, right? And requested at a hard cap of 1 CPU. That is why that this command will show sometimes 244 MB, maybe beyond up to 6. You can see that it is still under 1, right? It is not going beyond 1. Similarly for the memory, if you see here for the memory as well, it is sometime 104, right? But why? Because maximum is 256 we are saying, right? And 256 is already allowed, right? So for this, as of now, there is no kind of problem, right? But for this, you can see that it will never go to up to 2, right? So now let's do one thing. Let's delete this code and let's change some argument in the memory, okay? Delete pod stress code. Okay, let it delete it. Now we have this file, right? So what I will do is I will say fork this process, right? One process will be 500 MB. Okay, now we are out of memory range. You can see that memory limit is 500. Now let's see what will happen. Okay, and now if I'm gonna create it, yeah, it's up and running. Now put that watch command now. It will be available all these metrics, right? Because it needs to read what is happening. Maybe inside the stress command will start and it will start stressing the CPU and memory. Then we'll see that what will happen. Okay, it's not started yet. Should be running. Okay, let's try to describe the board. Let's see what is happening. Describe pod stress-pod. So here we are successfully and failed container in this stress. It is failed, right? Back off. Why? If you go up, so you can see that last state was terminated and you can see out of memory killed, right? Why? Because guys, you know that we have set it limit to the 500, right? And we are saying that 2 kind of instance will be generated and in total it is beyond 512, right? It is up to 1024 and that memory is not allowed for from this the namespace limit perspective, right? So obviously your board will get out of memory killed error and it got terminated. That's what I was trying to say, right? For CPU, right? For CPU, it never be the case, right? That's what I mentioned because kernel namespace, the C group will take responsibility of this CPU, that whatever that limit you are putting, right? Beyond that, you cannot go and do that stuff, right? So that's what that you can see. If I check the port status, so you can see it is crash loop back, and why? Because it is not getting that particular memory and everything, right? You can scroll up and you can access this. Very good. Here you can see that, right? This is the reason it is out of field. So that is the reason, guys. It is the possibility like you can do, and you can set all these limit, right? Let me delete it. And whenever you are doing, right, you need to make sure that what is happening to that particular node, right? If you describe this node, right, so earlier, okay, maybe as of now I cannot show you, but you need to understand like how much of memory and CPU you have, right? Total limits may be over 100% and over committed, right? So if like the native process will get suffocated due to this other code process, right? So maybe your node get unreachable, right? So you need to understand that as well whenever you are defining, right? So to make sure that, okay, what is the maximum CPU and RAM is available, if you want to put some kind of that stuff, right? Like you want to see, okay, if a particular a node is having, let's say, some kind of, let's say, SSD, right? This is SSD. Then only that particular code will gonna deploy that, right? So all this stuff will come under the taint toleration and the node affinity, because label and selector we have already seen, right? But still we will gonna discuss a few lines for this. But we'll start in the next video the tone and toleration, right? So that's how that you can think about this stuff, right? Because it is the concept of this request and limit in the Kubernetes, right? Which can kind of give a guarantee for minimum and maximum what is allowed, right? And that's what we are doing here. All right. So if you find this useful, then again, don't forget to like and subscribe and share it with your friends preparing for the CK exam, or maybe just to understand that Kubernetes, what the Kubernetes, how it works, and all these things, right? So yeah, that was again the limits and resources in the Kubernetes. In the next video, we will see the tone and toleration, right? Taint and toleration, sorry, right? How it works and how we can make it happen. That's it, guys. I will meet you in the next video. Till then, bye-bye.